All right. So this is my presentation. I told my daughter I was coming to do a presentation at a conference, and she wanted to come do a presentation as well. And then I told her no, but that I would put what she wanted to talk about on the first slide. So these are her favorite foods. These really aren't her favorite foods. I don't know why she said these things, especially the cornflakes part. We've never eaten cornflakes at our house. Okay, so we got that out of the way. All right, so give me symbols if the mic is a problem, someone. So the talk is called Right to Go Faster. And that really doesn't mean much of anything, but I kind of think it sounds cool. So I'm Peter Tomaselli. I work at Wayfair on the iOS app. And what we're going to talk about is a sort of functional programming influence technique we use in our production app to improve performance. So goals/reasons for this talk existing. This is pretty small, modest technique, but I haven't really seen it described anywhere. So perhaps, now that I'm saying this, I'm sure someone can find something. But I think this is somewhat novel, maybe just for iOS people. You don't usually hear about functional programming. Well, I shouldn't say usually. Sometimes you are asked to spend performance to use functional programming in a code base for reasons of correctness. But that's not what this is about. This is about we have a problem, and what we're going to turn to solve that problem is functional programming. So I think that might make this a little bit interesting. And kind of similarly, a lot of times, some of the time, you may see talks about prototypes or brand new libraries. Everything that we're doing here is production code that we've been using for about a year. So hopefully that should also make this a little bit interesting. So I'm a little bit worried about the timing and organizing. I got notes, I got slides, I got a playground. So I want to say up front what the structure of the talk will be in case we get off track or I have to speed up or slow down. So we're going to describe the problem, hopefully pretty quickly, just with some screenshots and stuff. Then we're going to do this right to go faster, sort of tiptoe up to the writer monad, like what it is, how we're going to use it for our thing. And then we're going to sort of come out of that, so that's number 2. And we're going to come out of number 2 with kind of like a little tiny gadget that will do good things for us. But we're going to need to sort of put that into some sort of structure or strategy that we're going to use to fix a big, larger problem. And so we're going to use reducers to do that. So that's 3. We're going to sort of embed this thing in reducers. And then there might be another section after that. I don't really know. We'll see. OK. So this is the part of the Wayfair app that I work on. It's called the product detail page. I may say the acronym PDP at some point. Probably everybody has either used this or knows what it is. It's just you're browsing around at rugs, for example, and you've tapped on one that you like, and there's a big scrolling thing with some features and buttons and pictures and all kinds of stuff. So we build this up at runtime. There's about like 20 to 30 features live on this page every time it spins up. And they're kind of stacked vertically. There's a couple more screenshots. Yeah, so if you were to scroll down, you'd see a bunch of other stuff. So some background for you, and I hope I won't take too much time because the exciting part comes later. So this code is highly modular already, so hooray. There are many child view controllers in this picture. If you kind of slice it horizontally, kind of like every chunk is implemented separately. We can turn them off, turn them on, move them around. So that's all good. The challenges come when we manage the data for this page. So obviously, we need a consistent view of the data to present to the user. So even though we've modularized how this is implemented, we need to talk to a shared data store. So if you were to diagram it, there's many child view controllers on this screen, but there's only one data store, and they all need to communicate through that kind of choke point. And the data store is sort of fundamentally asynchronous. We don't have to talk about like asynchronous patterns, really, just to know that data flows through the data store at any time. So the network loads it, the user may change things, and it's all flowing just live. and it's broadcast from the data store to these interested parties, all these little child view controllers. Okay. Okay, so here's where the problem starts. The data store makes a bunch of different kinds of data available, and we want to say, hey, all you child view controllers, grab whatever you want, and we will, you can subscribe to it, and we'll tell you whenever it changes. There's some pieces of data, though, that are very popular. A lot of people want to know about them, like the price or what's in the user's cart. And so a single change to one of those popular pieces of data may fire a dozen callbacks to these different pieces of the UI. And each one of these pieces of the UI will attempt to react to that by updating its view. And this is all serial. Obviously, it has to be on the main thread. And worse still, all this stuff lives in a big collection view. So a lot of the times, these view updates have to invalidate the layout of the whole collection view. And so you can look at this in instruments, and it's this giant tidal wave of changes based on one single change in the data store. So this kind of multiplies or fans out as it happens. OK, so that's the problem. And now I'm going to fast forward. So imagine we just investigated that problem, and we figured out what actually is going on, because I want to talk about the solution more than more talking about the problem. So I would say the problem that we have is about the granularity of the data that we can subscribe to. So we can only say, I want to subscribe to the cart. But if you implement a feature, you don't care about the whole shopping cart. You probably just care about a couple pieces. And so what we found when we looked into this is that even though there's this huge pile of work that's fired off, many of these views don't actually change what they look like before and after. So we need to sort of no-op many of these updates. But we have a couple constraints on the solution that we can come up with. One is that we can't really significantly change what our data store or how our views are implemented, because we have a lot of code and we need to keep it rolling forward. And there's no sort of universal or general way to implement this. Every feature has its own rules about what it considers a no-op, what it's going to react to in different ways. So we can't write one function or one class to do this. We need to sort of invent a way to talk about this in kind of a fluid way, like some sort of DSL or something. OK. I think that's most of the slides, thankfully. OK, so we're going to do this thing, and then we're going to switch to the playground. So this is a struct that we are actually using. This is the definition of the struct. We call it changeable. It has a value of A stuck inside of it, and it has a flag. And you can think of this like the dirty flag. So when the flag is set to true, we know that this data has been changed, and we need to react to that. Otherwise, it's set to false, and we know that nothing has changed since we spun up this change tracking. And now I'll sort of show you how that works. OK, cool. Maybe bigger? All right. Does that look right in the back? Bigger. OK. How's that? All right. OK, so this is a playground. We've imported our library. So there's a bunch of cool stuff hidden that I will show you now. But the first thing we're going to do is I'm going to introduce a function that uses that changeable struct in sort of the way that we want to use it. So I have a little macro for that. OK. Yeah, that's pretty readable. So what we're going to do is we're going to start with this struct called person, and we're going to pass it to this function called change first name. And we have very important business logic implemented in this function. If the first name of the person is the word hamburgers, then we don't need to do anything. It's all good. Bigger? Yeah, can do that. Is that good? OK. Yeah, so our goal is to change the name of this, the first name of this person to the word hamburgers, but we want to communicate back out of the function whether we actually changed anything. So you can see we check whether the first name is already fine, and if it is, we create this changeable wrapper, and we set the flag to false, and then we just pass the value back out. Hopefully that's pretty clear. So I'm going to just do person foo var. So if we evaluate the flag, we don't need to see that the struct has been changed probably, but the flag evaluates to true. OK, cool. I see a handful of nods. That's good. All right, and just to illustrate to make it super clear, because I think this will help us later on, we'll do hamburgers and something else. And that is false. OK, hopefully everybody's on board with that. OK, so as is the way with most functional programming thingies, right? Let's figure out what happens when we have two of these things and how is it going to compose together. So I have another function that is also very important. It's this one. And this is the same, except we're going to change the last name of the person to Kale. But our goal, I want to be super clear, this might be a little bit redundant for people who are ahead of me on this, but our goal is to execute these two changes, and we want the flag to be set appropriately for sort of the composite change. So we want to do two things, and then we want to know, OK, you just did two things. Tell me about those two things together. So I'll illustrate this by doing what I think is going to be the hardest part of the talk, which is write this by hand. So we're going to kind of do like first change equals, we got a person. Then we go second change. And we're going to change the last name. We got to use the value we just created, but we got to reach inside and get the value because that's wrapped. But we're not done. We also have to kind of like create another variable of some kind because we got to go get that other flag that we left behind. So maybe I can format it a little bit like this. So we kind of want the first change flag. And if you follow what I'm saying, we want to OR these together because if any change happened, the whole thing gets dirty, right? So this is going to be second changed as change, and then we're going to grab the value from this one. Maybe we can evaluate that. OK, so hopefully we're following that so far. So we want to execute these changes and then be able to know something about the whole string of changes by the end. All right. So I don't want to write that ever again. That was very frightening. So we want some sort of helper function, perhaps. So we can put an extension on changeable. All right, let me see. Yeah, so what we're going to want is like a function. It's called like perform next change. And this is going to take like a transformation function form. And it goes from A, which is the value that's already inside of this changeable, to a changeable of B. And this should put out a changeable of B, which is because we're combining the flags. So we could write this, but I think, I don't know, there's a lot of people here. Probably many people here know the actual name of this function, which is flat map on this type, because we're producing a transformation and then we want to collapse one level of it. So I'm not going to write that. I'm just going to use it, and we can see what it does for us. So if we kind of bend our way back to thinking about flat mapping, we're going to kind of like start out from scratch. So we're going to lift up our person into a changeable wrapper, and then we just flat map our two functions onto it. And this is like, whoops, like your standard flat mapping stuff. And so this sends through the flag the same way as the other thing. So flat map, we've like discovered a flat map, right? We kind of tiptoed our way up to it. So the next thing we want to look at, OK, so brief interlude. All right, so if you're like me you get excited. Look at this. We found a flat map. So like I'm going to go into work tomorrow and go to stand-up, and I'm going to say, OK, I figured out our problem. Everything's going to be fine now. All we have to do is rewrite all our business logic in flat mappable shaped functions like these. And then we're going to rewrite all the code that calls the business logic to use flat map a lot. And as long as we do those things, those two very simple things, then we'll be fast again. So my advice to you is do not do that, because people will not accept that as a proposal quite yet. And it's not because this is a bad idea. This is actually a good idea, but we just haven't gone all the way with it yet. We got to make it a little nicer to use. So we're gonna. This is the whole idea, but now we're going to start making it a little nicer to use. OK, so the first thing that's really low-hanging fruit that I'm sure everybody here is down with is I don't want to write dot flat map like a lot. That's a lot of typing. So we're going to put in some of these guys. This is just, sorry, what happened here? Just the bind operator. So this is just an operator. You can tell your friends. This just means flat map. No reason to get upset about it. But now you don't have to type as much. OK, so that's cool. And the other thing I like about this, I'm actually being serious now, is that this kind of says, like, OK, you're in DSL land. All right, so everybody, like, if you see this, you're scrolling through code, it's like, oh, something is going on here. And so I actually like that. So that's like one thing we can do to clean this up a little bit. But there's a huge other problem that we haven't talked about, which is that these functions up here, I don't like writing these. We've just sort of moved the tricky part of doing this task into these functions, right? I don't want to do this. I don't want to have to think about everything I want to do in terms of these functions, right? So what we need to do is figure out some way, like talk through, OK, what is this function actually doing? Can we come up with a better way of doing this? So if you look at one of these change functions, what we want to do is, or what are we doing in this function? We're sort of taking this big thing that we've been passed, and we'll call that like the root. That's just like a word that popped into my head. And we are going to kind of go to a particular location in that big object and like look at something that's there and make a decision about it. And if something about that location we're looking at meets some criteria, we want to write something at that location. And then depending on what we did, we need to sort of set a flag on this changeable thing when we return it. So that, perhaps, is suggestive to you of Swift key paths. So what we kind of want is a function, and we'll call it like write. Whoops. All right. And we kind of want to write like a value of some kind, add a key path, which is a writable key path from A to that value. And then this is maybe, I don't know, maybe a tricky part, maybe not. We want to stop with the parameters for this, because what we want to receive back is a function, sorry, that takes an A and will return a changeable of A. I got to put these over here. So in other words, we want to provide two parameters and then wait to provide the whole thing later on. And what that does is that makes this write function like a flat mappable function generator function, I think. So this is also in the library, so I'm not actually going to implement this, but I'll show you. Hopefully this will clear it up if the playground cooperates here. So we got to go changeable.write. And we're going to write, what was it, hamburgers at first name. And then we're done. And then we're going to changeable.write kale at last name. OK, cool. And so this, I'm super pumped about this. This is like looks very declarative. The functions that we declared up at the top, we don't need those anymore. We just delete those. And so that's what this overload of the right function does. It just generates a function that you can then flat map pretty easily. Let's see. Cool. So I'm feeling good about this. So let's do like another quick kind of example just to tie it back to that problem I was talking about. And then we'll do like the final bit. So I have another macro. Cool. Let's see if we can fit all that. OK. So this is a pretend view controller. All right, and we have this view controller has some state, which is just for ease of use is this person that we've been using. There's a property observer on that state that updates the UI in a very expensive fashion, as you can see. And there's like this view controller, this fake view controller has a callback. We can push data into it. And I teed this up so that you can see this view controller is going to hit the UI in an expensive way, even though we sent it data that is identical to what it already has. Hopefully that makes sense. So we're going to do, we just have to stick our new thing in here. And this is the other hard part of the doc. So we're going to say like the next state. Sorry. State. And then we're going to, this is, I left this the same as what we did above so that I would actually have a chance of doing it. We're going to write our parameter that we got first name at first name, lots of typing. And then last name goes at last name. OK. Oops. So and the reason I wanted to show this is just to show you the rest of the boilerplate that we need here. We're going to kind of just go like if next state has changed, then this thing's state equals that value. And hopefully, cool. So hopefully that made sense. Let me scroll up a tiny bit. You can see that we've squelched this update, right? So good. So that's kind of, let me just look at my notes here. So that's like part one. And I am happy with this. But what happens when this is not a toy example, right? This data-to-update function gets enormous. And we haven't really provided any guidance for people what you do when that happens, right? It's just like use the bind operator until you're happy. That's not going to fly. So what we want to do is put this into a bigger, I don't want to say the word architecture, but some sort of like bigger thing. Because you remember we have 20 or 30 features that need this, right? So we need to like give a recipe, give people a recipe. So I think I have one slide that might help us. Playground time. Yeah, okay, so we're going to do, we're going to just stick this in some reducers. And here's one way to define a reducer. If we call A to be like our state, and we call X to be like an item in a sequence, or a new event, or an update, or anything, then this function next is just a way to combine that event or new information to get a new A. Hopefully that makes sense. I think Brandon has done like 2 talks about this, right? So what we're going to do is we're going to pretend, we're all going to go on an emotional journey together, and we're going to pretend that data-to-update is a really big function now. And we want to sort of fragment this out into reducers, and then that'll allow us to build it back up and move them around and do cool stuff. So this is actually the hardest part of the talk, I think. So we're going to say, I'm going to define 2 reducers. We're going to pretend that we want to separate first name and last name, processing them. So if we say like process first name, this is going to be a reducer. The value that we're going to be accumulating is going to be changeable a person. So it's already going to have been lifted before we send it to the reducer. And then I'll just kind of cheesily do string, string. This will be first name and last name. And then this is going to kind of go wide. Next partial result. which is just a static function we have to build a reducer quickly. And we get a person and tuple in. A lot of typing. Oh boy. And then we kind of want to return person, find, right, first name, at, first name. And then we're going to, if you can believe it, type all that again to process the last name. So we're taking our business logic and we're pulling it apart in a way that we know we can put it back together again at the end. Last name, last name, last name. So this should, let's just make sure this compiles. All right, cool. And so now we're just going to tweak our boilerplate a little bit. And I don't want to toot my own horn too much, but we're not going to have to change very much in order to do this new reducer approach. We're going to say process first name. We're going to combine this reducer with the process last name reducer. Just do both things is all that means. We only have to run it once, so I'm just going to reach in and grab the function because we just want to run it once. And then we need to definitely not forget to lift our state. Oh, this got really wide. I think I need first name and last name here. And maybe I can like format this for the people in the back. Okay. Let's just test it by sending in actually new data. Cool. All right. So that was a lot of typing. The basic idea is that when we want to do a lot of writes, we can pull those writes apart into multiple reducers however we want, right? If we want to do first names over here, or last names over here, or if you have addresses and accounts, or stuff you want to do on Monday, stuff you want to do on Tuesday, it doesn't matter. You can pull this stuff apart however you want and put it back together again when you need to. And so I have a list of things that this lets you do that are good things. Right, so we can do this grouping, right? Whatever sort of semantically makes sense, we can group reducers like that. We can unit test these reducers in isolation, right? So if I want to write a test that just makes sure that I do the right thing with the last name, I have that as a first-class thing now. And actually, I have that, and I also have the behavior with respect to the flag that I can get under test as well, right? So I can test, given a state and some new data, is this going to no-op an update for the UI? I can put that under unit test, so that's good. We can, at runtime, decide not to use one of these, right? If a feature flag is off, I'm just going to make my reducer stack down here one reducer smaller. So that's pretty handy. And we can share code as well. You know, if someone else has written, you know, process last name is really complicated, someone has already written that, I don't have to write it again. I just go grab it and stick it into this stack that I have. So all of that is good stuff. And all of that is stuff that we actually do with these. We have a ton of tests that just test the reducer and nothing else related to these updates. And we do have tests that ensure, given a certain state, we will not update the UI. We can actually test that. So that's cool. And the only other thing, OK, so there's one last thing that I wanted to mention about this is that reducers and this changeable thing, they sort of exist. They coexist peacefully, right? They don't affect each other. Changeable is one thing. Reducers is another thing. You can interweave them, but they don't change anything about each other. All the laws of each one are the same, regardless of whether they're mixed or not. Cool. OK, so there's just one last thing, which is the surprise ending. Right, OK. So this is the best part. OK, so this is what we did for a couple months. And it's pretty nice. I like it. But this kind of stuff right here, like if you take this chunk, people don't necessarily, not everybody likes to write code like that, right? There's an operator in there, it's a closure, you had to write this big type at the top. I don't have a slide for this, but at some point, I'm pretty sure someone in this room in some form of media pointed out that, I don't remember who it was, that there's sort of an equivalence between functions that go from A to A and functions that go like in, out, A to void. And so the thought occurs, what would this, if we sort of flip that switch for this whole thing, what happens? So let's see if we can actually do that. OK. So part of the reason that this was hard is because I had to make sure I didn't do it this way starting out. So if we use the initializer that we have on our reducers, then this becomes an in-out reducer. And so then my job in this reducer is to mutate the variable called person. I don't really have a good way to do that yet. So I'm going to just leave everything and do this. OK, so now we're sort of looking at this. And it's like there's a really obvious like API that's like looking at us in the face, right? Which is we want to flip this in-out switch on the other thing that we just built, right? We talked about reducers, we talked about changeable. So the API that I want is I want to just do this. That. And that's the method we have. And so now, let's just make sure it still works. OK. And so this is the way we do this now. The reducer is in out, and write is now an extension. And I want to see if I can get it here. Yeah. OK. So the really cool thing about this is this takes the flat map or the bind operator, and it like sucks it into the library, right? So people who might be alarmed by that kind of thing, they don't have to actually see it, which is good. But the cool thing is it's still there, right? So everything that we know about monads and flat mapping and all that stuff is still in here, right? We've just put it out of sight. Let me see if I can go back. And the other thing is this reads much better, like straight up it does. And it's super declarative, and it just says what you want to do, right? You just write stuff to where you want to write it to. And I actually think this is like, once you get used to this is more readable than what regular mutable code would look like here. You'd be doing all kinds of crazy stuff. Let me see if I have one more slide, and then I think we're all set. Reducers. Something else? Oh, all right. Yeah, so this is an open source library that we just raced. A bunch of people helped me to pull out of our app and put up as open source. It has some other stuff in it too, so it's our like functional prelude. Sorry for anybody else who has that name. But you can grab it. This playground is the library. Like this is the playground you get with the library. So if you pull this down, you get this thing that we just did. I haven't written a README yet. That's my fault. But you just saw me perform the README, so that's fine. And I think that's it. We're hiring at Wayfair if anybody wants to chat about this kind of stuff. And thank you very much. Questions? Yeah. Sure, yeah.
Time for one or two questions.
Repeat the question. Repeat the question. I can do that. Anybody? We don't have to do questions. It's early in the morning.
Do we have a mic or?
We'll repeat up here.
I'll repeat them.
Okay, so my question was, when you deal with mutable structs, sometimes, which is basically not a good pattern, but sometimes you have the sets on some of those properties, right? And so you update one variable, and under the hooks it updates like 5 of them. So how do you deal with that? Do you kind of just forbid this practice in your code, or because it will, like the changeable will monitor only the property that you're actually changing, right? Just only the one property.
Right. So that is, I think, a good question. The question is, maybe I can summarize it. how does sort of the cascading setters of structs, value types, interact with the changeable thing? I don't think I have a good answer for that. I think what I would say is we don't tend to go too many levels deep because we tend to have state in the view controller or whatever that is built for that view controller, so it's flattened out. The other thing that I didn't have the chance to mention, but if people want to check out the library, there's an applicative instance for changeable, which is kind of this deal, which is to say I have 3 things that have change flags, and I want to build one big thing and have the change flag propagate correctly. That's essentially the applicative of this. And that's in the library. Just didn't have a chance to talk about it. So it kind of answers the question, hopefully. Thank you. Cool.
How big is the wafer team, and how have you found adopting functional programming style in that side of the team?
How big is the Wayfair team, and how has functional programming adoption been? We have 50-ish iOS engineers. And right now, so we all work on different features. Just mostly the people who work on this feature with me, so that's maybe like 5 people, are really working on this. But we also have people throughout the team who are into functional programming as well. I think the big thing, I mean, this is a huge question, right? The big thing is right now this is opt-in. You don't have to use this. So we try and invite people in, but if they prefer not to, we'll get them later, I guess. All right.
You mentioned about that this helps performance, but how do you prove that that is actually better?
That's a good question. How do I prove that this performance is better? So I don't have good numbers because we were doing other performance-y things while this was implemented. But there is a really fun way, which is you can go into the definition of this thing called changeable that we did and break it. You can say the flag is always true. And then we just rerun the app with our diagnostics. And then basically it becomes a struct that's doing nothing for you. And so what we found, so we've only done this informally. It's about 500 milliseconds per page load that we're getting from this so far. And that's with just a little bit of adoption. So we have that's benchmarks and stuff are something that we need to do, but we've only done it kind of casually.